Good morning, everybody. So, I wanted to at least make a video for section 2.7 regarding how to deal with absolute values and inequalities. It's a lot of information that's going to come out on this one, so it's going to be a little bit longer, and my apologies for that. So, first of all, you can have an and or an or. An and is considered an intersection, or where the sets overlap. Or is a union, and they don't have to overlap. They can be one side of the number line or the other side of the number line. So let's begin with an example and say we want to solve this. It's the absolute value of x minus 1 is less than or equal to 3. And my comment is you need to realize that whenever you're dealing with absolute values and there's a less than, treat it as an and. Now, I'll give an example later where it's a greater than, and then we treat that as an or. Okay, so I have this, it's almost rhyming, so less than and, it almost rhymes. It's not perfect, but it almost rhymes. And great or is or. And it's really greater, but great or gets close to the or. So, and because we have the absolute value, like we talked about before, we have to treat it as a positive and a negative case. So we get two branches like we did previously. So for the positive case, everything remains the same. For the negative case, on this branch, we put a negative in front of everything that was on the inside of the absolute values. So we we solve this, we add 1 on both sides, and we get x is less than or equal to 4. And again, it's and because it's less than. And you're going to say, but what about the or equal? Well, less than, or equal, it's still an and, okay? I pass my negative through, and I get a negative x plus 1. I'm going to subtract 1, and I get 2. And I'm going to divide by negative 1. Bing, 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 bing. Okay, we divide by a negative, so we flip the direction of the inequality, and this now becomes a greater than or equal to negative 2. And if I draw the number line, okay, now a little quick aside. Less than or equal to, greater than or equal to is a solid dot or a closed bracket. It takes more ink to draw these objects. Now, it takes less ink comparatively to draw these objects. So if you have a less than or a greater than, it's just a hollow dot, or you use the arced parentheses to indicate. Okay, so more ink, less ink. Okay, they all fit together. So here's my negative 2. I'm taking all the values that are larger than negative 2. So that's off that way. And then all the values that are smaller than 4, that's off that way. Because they are or equals, that's why I have the solid dots down. And the values that are greater than negative 2 and at the same time smaller than 4 are these values that are between negative 2 and 4. Okay? Now your book sometimes will talk about set builder notation. So we would write it as x is such that x is greater than or equal to negative 2 and x is less than or equal to 4. Or more commonly, you're going to see it as x is such that negative 2 is less than or equal to x. So that's saying all the numbers are bigger than negative 2, and at the same time, those values are smaller than 4. Another way to say it is the values of x are in between negative 2 and 4, and you'll notice the arrows point to the left. They do not point one right and one left. They all point to the left in this notation. Okay. Yeah, I was being pretty emphatic there, so it's important that you catch that. Now, what happens if you have a greater than? Well, we'll take an example. We have 1/2 times the absolute value of x minus 3 is greater than 2. Now remember, greater than is or. Sorry for the yawn, folks. All right. Well, I need to isolate this absolute value, so I'm going to multiply both sides by 2. Now, please note, when I multiplied, the number was positive, so I do not change the direction of the arrow. If that was a negative, this side would have to be a negative, and it flips the direction of that arrow. Well, the 2's cancel. And now I'm down to an expression absolute, not expression. I'm down to the inequality. The absolute value of x minus 3 is greater than 4. Well, I have two paths. I have the positive path and I have the negative path. The positive path is x minus 3 is greater than 4. I'm going to add 3 and I get x is greater than 7. Or I put the negative in front of the x minus 3 and I see I'm going to distribute my negative, and I have now negative x plus 3 is greater than 4. I subtract 3 on both sides. Notice it's a subtraction, so I do not flip the inequality. But over here, I've got a negative x. I'm dividing by negative 1. When I divide by a negative or multiply by a negative, it changes the direction of the inequality. A quick aside there, you might ask the question why. Well, we know that 2 is greater than 1. And if I divide both sides by negative 1, I now have negative 2 and negative 1. Well, in order for the truth to still sit there, that now has to go this way because negative 2 is smaller than negative 1. Okay? All right. So if I graph it, x is less than negative 1. Now it's a less than, so it's a hollow dot. Less ink. Off to the left, and the other inequality was x is greater than 7. So at the 7, I'd put a hollow dot off to the right. And this is the graph of it. Now, I have x is such that x is less than negative 1 or x is greater than 7. I don't have the ability to do anything like this. It's two separate branches, and the values can be over here, or the values can be over here, and they work. So if I pick 8, and I plug it in to the original. 8 minus 3 is 5. A half of 5 is 2.5, and 2.5 is bigger than 2. And if I take a value like, say, negative 10, negative 10 minus 3, negative 10 minus 3 is negative 13. The absolute value of negative 13 is 13. A half of 13 is 6.5. 6.5 is bigger. So the values over here work and the values over here work. These values don't work. Okay, hopefully that helps. All right, have a good one.